So one of the nice things about the can example is it shows how the production of materials and goods can happen in many, many different steps of sort of interconnected processes. And one thing that we can do to try to understand the process of life cycle assessments more generally is we can start to generalize the different stages that contribute to the production of goods and services. For one thing, you might have the raw materials stage. Okay, in the case of the aluminum can, this might look like the mining process for the bauxite ore. Then you might have a production stage where you're actually converting those raw materials into something that's actually useful. So for the aluminum can example, this might be quite extensive. It might include the production of the alumina powder from the bauxite. It might include producing aluminum from the alumina powder. It might also include the actual fabrication of the can, as well as the shipping and distribution of the can to and from the grocery stores that actually sell supermarket goods. Then for many items, there's the use phase. The drinking of a soda out of an aluminum can doesn't necessarily have a huge environmental impact, but you might think about things like cars. When you use the car, it has an environmental impact when you burn gasoline, and that might very well be the largest environmental impact associated with that item. You might also think about items like electronics that have environmental impacts along the way. And then finally, there's the disposal phase. This can look like physical material being thrown in landfills, liquid materials being disposed of into bodies of water, gaseous materials being emitted into the atmosphere, or in the case of the can, we have a whole series of recycling steps that might be complex and involved in their own right. Now, there's a couple different types of ways we can go about calculating life cycle assessments. If you consider all of these phases of production, use, and disposal, it's called a cradle to grave calculation. We want to look at the total environmental impact all the way from the mining of raw materials to the final disposal of those items. But oftentimes, life cycle questions really focus on optimizing the production process to either make them more environmentally friendly or more efficient in some other way. And when the production process is the main interest, oftentimes we only consider the cradle to market life cycle. So we might only consider the environmental impacts created from the raw materials and production stages of a particular object's life cycle. So what kind of impacts might we consider in a life cycle assessment? Well, for one thing, we saw our can probably, the production of a can uses tremendous amounts of energy use, from the mining of materials to all the processing steps to all the transportation that's involved. And we can try to quantify energy use in things like joules or kilowatt hours or BTU. Alternatively, you might look at greenhouse gas emissions, which are related to energy use, but not necessarily exactly proportional to one another. For example, if our can used a lot of energy in Iceland to actually smelt the aluminum, and that electricity came from renewable sources, they might not necessarily result in lots of greenhouse gas emissions. There's lots of water use in the production of our can, all the way from the mining stage through the fabrication stages of the can production. And there was certainly lots of waste produced, both in solid, liquid, and gaseous waste forms that can be measured in units like milligrams, grams, kilograms, and pounds. And also there was land use associated with mining and waste disposal. When we're carrying out a life cycle assessment and we're interested in these various impacts, the process for quantifying those impacts is usually going to look the same. The first step is going to be determine your functional unit, i.e., what is the amount of the thing that you're interested in calculating the environmental impact for. In the case of our aluminum can, it's just going to be one can, but it can be more complicated when you're looking at different types of objects and services. Next is going to be to estimate the environmental impact of that process. So, how much energy does the mining process use? And once you determine the environmental impact of the process, you can determine the environmental impact required to produce one functional unit. So if you go to the mining operation and you figure out how much material they produce, and you also figure out how much environmental impact that operation has on the whole, you can find the proportion of that environmental impact which is appropriate for your individual functional unit. And then the next step is to repeat this for every stage of the life cycle. For the mining operation, for the alumina production, for the aluminum production, for the can fabrication, for the grocery store, for all of these, you basically want to detail all of the environmental impacts that they're having, and you want to be able to calculate the portion of those environmental impacts that are associated with the single can or the single pair of hands that are being dried or the single car that is being produced. So you can start to get a sense of how complex and labor intensive these life cycle calculations can be, especially if you're starting from scratch. Because of this, there are now lots of tools out there to help us carry out life cycle calculations. For one thing, there are large data sets which tell us all about the environmental impacts and amount of materials that are produced by different industries around the world. And there's also software packages that can let us string a whole bunch of different processes together and calculate a whole bunch of different environmental impacts all at once. Eventually, we're going to get into using software like this, but first we're going to begin by looking at life cycle calculations that have already been carried out by other researchers.